Welcome everybody, I hope you are doing well. Today's lecture we're going to talk about the solar angle. So let's start. There are three main types of solar angles for the PV solar system. Let's start with the first type, which is called the declination angle. It's basically can be described or explained as the angle between the Earth's axis and universal axis. Let's suppose the universe has an axis connected between the Earth and what out there, and the angle between the universe axis and the Earth axis called the declination angle, delta. This value of delta or declination angle is basically varying depending on the motion of the Earth around itself and around the Sun. The declination angle has a range between minus 23.5 up to 23.5. To understand it in more details, let's explain it all over the year. Let's suppose we have the Sun and the Earth all over the year, each quarter all over the year. At the first part here, and its second part right here, and in the third part right here, and in the final part right here, each quarter separately. At the first part, the declination angle is typically 0, as the angle between the universe axis and the Earth axis is typically 0. It basically occurs when 21st March in spring. At declination angle equal to 0, we will have typically the day time is going to equal to the night time, as typically the left side is going to be the same as the right side. So the right side of the Earth is going to have the same time on the left time of the Earth. Okay. After quarter of year, we're gonna get in 21st June, the summertime. The delta angle is going to be equal to 23.5. So the declination angle is going to vary from 0 up to 23.5 with a wide range, until I reach its maximum value at 23.5. At this time, basically, the time of the day is going to be larger on the time in the night. That's basically done due to the angle is increasing, allowing more sun to be facing the Earth. After another quartile of a year, in 21st September or autumn time, the delta angle will come back to 0 again. So when declination angle becomes 0, then again what will happen the same here. The day is going to equal the night, as the same both half of the Earth is going to face the same time. Okay, now let's talk about what would happen after another quarter of year in 21st December. And when basically the declination angle now began to decrease and going to be reduced to minus 23.5. This is going to cause the light facing here, the sun, is going to be less. So the daytime is going to be less than the night time. Okay, after another quartile of the year, we are gonna go back to the first position. And this is can be described as the entire season of the year. So the delta angle, declination angle, basically could vary between minus 23.5 up to 23.5. In the summer, it becomes highest value at 23.5, and the sun hour is going to be higher due to the daytime is larger than the nighttime. But in the winter, the declination angle is basically equal to minus 23.5. Daytime is going to be less than nighttime, which causes the sun hour is going to be less in winter. Now, let's learn how to calculate the declination angle. As you remember, the declination angle depends on the time of the year. The declination angle basically can be calculated from this equation, equal 23.5 times sine of 0.986 times t plus 284. As t stands for the day in the year. What is the day in the year? To understand the day in the year, let's see this example. Each day in the entire year of 365 days is numbered by number from 1 up to 365. Let's take an example of 10th of March. At the 10th of March, the day number in this year is about 69. So when we put this value inside this equation, we're gonna calculate the declination angle as minus 4.862. Now, let's talk about another type of angles, the elevation angle. The elevation angle, it's the angle between horizontal plane and sun rays. Basically, if we have the horizontal plane in any part on the earth and the sun goes from sunrise to sunset, allowing the elevation angle to vary on the day. The elevation angle is very varying between two numbers, between 0 at the sunrise and 90 degrees in 12 a.m. or in the middle of the day. After that, the elevation angle alpha is going to be reduced again during the sunset until I reach 0. Then go again from 0 up to 90. So the elevation angle varies between 0 up to 90 degrees. The elevation angle can be calculated by this equation as elevation angle alpha is equal to 90 minus phi plus delta, as phi stands for the latitude of location in any part of the earth, and delta stands for the declination angle we have just learned how to calculate it in the previous two slides. Now let's talk about the last and final type of angle, or the delta angle. Basically, the delta angle is the angle between the PV modules and the surface of the earth. As the delta angle varying like this, could be reduced or increased, but also it has a specific range, cannot increase above it, or the solar panel will not be able to generate electricity from the sunlight. Basically, the delta angle T is going to equal 90 minus alpha, as the alpha is the elevation angle. So, to be able to calculate the delta angle of any PV module in any place, you will need to first calculate the declination angle, after that the elevation angle, then calculate the delta angle required for this PV module in your location. But the elevation angle, the delta angle, has a typical standard between 15 up to 60. So let's say if you calculate it from this equation, the delta angle, and you get it, let's say 23. We choose the next in line, which is 25. So this is a specific standard for the delta angle used in many projects. Okay guys, that's for today. Thank you for watching. See you in the next lecture. Bye bye.